Let's talk about the most common operators that are used in programming. The term unary means the operator works on just one thing, like positive and negative. There is another one we'll discuss down the line called the logical not operator. Multiplication works the same way for the most part. There is a distinction between integer and decimal value results. If the two values being multiplied are integers, the result will be an integer. However, if either one or both is a decimal value, the result will be a decimal value. This holds true for division and also for addition and subtraction. The modulus operator is most likely new to you, but the concept is one you already know and relates to division, specifically the remainder after division. In this example, the value 10 divided by 3 has a remainder value of 1, and we express this using the modulus operator and say it like this: 10 mod 3 is 1. These next few slides have more examples. Stop the video on each one and try to figure them out before the answer is shown. The answer to 15 mod 4 is 3, since the remainder of 15 divided by 4 is 3. The answer to 10 mod 6 is 4, since the remainder of 10 divided by 6 is 4. This one is a little tricky. Since it is not possible to divide 6 by 10 without going into decimals, the integer division answer is 0, with 6 still left over as the modulus answer, the same as the first value. The way I used to teach my students this was talking about donuts. If you have a box of 10 donuts, and you have 6 people at the party, with each person getting the same number of donuts as anyone else, each person will get 1 donut, and there will be 4 left in the box. But if you bring only 6 donuts to the party, and there are 10 people there, no one gets a donut, since there aren't enough for everyone to have 1, so there are still 6 donuts left in the box. The addition operator works just as it does in math. The only new distinction here is the same one we talked about earlier. When only integers are involved in the operation, the answer is an integer. As soon as the decimal joins the mix, the answer is a decimal. Subtraction follows in the same way as addition. The plus sign is also used with strings, but the operation is called concatenation and is used to connect strings together with other strings or values. In this first example, 2 strings are connected to make one longer string. Here, an integer is connected with a string, resulting in a string that contains the integer. You can also use variables with this operator, as you can see in these next 2 examples. The relational operators are used to compare 2 values, a very common and often used technique in programming. The result is always either true or false. There is a slight difference in the way the less than or equal to and greater than or equal to operators are typed. Since there is no keyboard character that is the traditional operator you would see in math textbooks, with the bar underneath left or right arrow, the equal sign is put immediately after the arrow to indicate these comparisons. The operator to check if 2 values are equal to each other uses 2 equal signs together, and is true when they are indeed equal, false if not. The not equals operator is commonly shown in 3 different ways, depending on the situation. Textbooks and printed pseudocode examples will most likely use the traditional crossed-out equal sign, as you can see here. Some text-based languages use the exclamation mark followed by the equal sign, or the left and right arrow combined. All of these mean the same thing and are true only when the operands are different. The logical operators are important as well, especially when more complex logic statements need to be expressed. The AND operator uses the double ampersand symbol in most languages and is true only when both operands are true, false otherwise. The OR operator uses the double pipe symbol and is true in all instances except when both operands are false. The XOR operator is only true when the operand values are opposite, true and false, or false and true. XOR means exclusively OR. The NOT operator simply reverses the state of the operand. Not true is false. Not false is true. The assignment operator we will use is the pseudocode version, using a left arrow followed by a dash. This indicates a right to left action, which means the expression or value on the right is assigned to the variable on the left. In the example shown, you would say, the integer variable x is assigned the value 5. Or you could just say, int x gets 5. For the next example, you could say, string name gets Joe. The increment and decrement operations are used quite often in programming, where the value in a variable is changed based on its current value, either adding one to itself, an increment, or subtracting one from itself, a decrement. You can add or subtract more than just one if the situation calls for it in the program, as you can see in this example. It is very important to understand the order of precedence for all of these operators. For the math-related ones, the order is the same as you learned in math. Multiply and divide in order from left to right, and then add and subtract, again, in order from left to right. The modulus is in the multiplicative family, so has the same precedence level as multiply and divide. Study carefully the order of all of these operators so that you are able to evaluate more complex expressions.